Use case number 2 is that the portion of EHR retrieved by a permitted requester depends upon the requester and the disclosure rules defined on the EHR. So let's take a look at an example policy. For the first use case, we might have a policy that a US board-certified physician can access medical data in any clinical document, whereas a locally certified physician can access only documents of type discharge summary. These are our types according to the CDA type system. Another rule could be that a billing clerk can access only the administrative data in any clinical document. And so only a physician is allowed access to medical data, whereas a billing clerk should only be able to access administrative data. For use case number 2, we might have a disclosure policy that a billing clerk accessing an EHR of category clinical document can only access the document in first week of any quarter in year 2005 for a duration of 1 week. This goes back to our requirement that people who are dealing with finance work according to certain specified billing cycles, and their access should be restricted only within that period. For another rule is in this policy is that a discharge summary, the resource access is restricted to occur only from within the state of New York, and this could be a state law. Now this seems like a very complicated policy to enforce given that multiple systems are coming together in the federated environment and the requirements are pretty fine-grained. However, let's take a look at our policy framework and our policy engineering methodology and see how we can address this issue. The key idea here is that we have to define the credentials, the assignment rules, and the constraints that we need to enforce on the assignment rules. And our policy engineering methodology will allow us to construct the policy based on these modular language components. So let's go one by one. User credential. The ID of the user, we will again use the any keyword because any requester can try to access the EHR, and it's not dependent on the identity of the physician who's going to access the records. So we will use the any keyword for the user ID. We will include a board certified ID attribute because the access rules will be based on the board certified ID attribute of the requesting user. And so you will just drag and drop the UML classes within your application and include the appropriate components that you need in your access control policy. For the role, we need 2 roles, physician and a billing clerk, and we need an attribute for the role called location. For the permission, we need 2 objects, clinical document and discharge summary. And the document will have 2 portions, medical and administrative. And we will include 1 operation called HTTP GET. Our current prototype supports HTTP GET operation. In future, we plan to add more operations. HTTP GET allows you to access a resource online in a read-only mode. And that's probably how you access your websites every day. It's usually an HTTP GET operation. Next, we need to define a temporal constraint. And for this case, we will include a periodicity object and define a constraint valid for first week of any quarter. We will then need to include an interval object for year 2005 and a duration object for 1 week. All these come together to form a single temporal constraint. Finally, we will define the assignment rules. And for the user role assignment rule, the board certified ID would be either US or non-US, depending on the role. For the permission to role assignment, we will include the temporal constraint, and we will set the location attribute to New York. Sounds like a fairly straightforward way to implement a very complicated policy, but this is just the specification part. How do we move on from here? So remember, our UML profile for XML schema design allows us to translate this UML into an XML schema, which will then be used deployed in the system architecture we discussed earlier. And the XML schema documents will then be parsed by a custom parser that we have designed, and it will be able to store the policy information into Java objects within the system. And the Java objects will then be used by the session management module to enforce the access control policy once the users request access to resources. And so this is how we move from the specification stage to the meta modeling stage, and finally we translate the UML meta model into XML schema definitions and we move from specification to meta model and then to XML schema system, which is then translated into a Java bytecode, which enforces the access control policy. So you can view this policy to be represented at several levels of abstraction. The most formal being the BNF grammar, then it's abstracted out as a UML meta model, which then gets converted into XML schema definition, and finally Java classes and objects. I have links to the complete Java documentation of the Java classes in the paper, and hopefully it will be available in my thesis also. The prototype we have implemented is available in 3 versions. You have Windows-based shell, Unix-based shell. We have a Java web start to access the system from a client desktop, and we can also access it online from a web browser. I'll see if I have time later for a demo, or we can do it after the talk as well. If some of you are interested, you can come to me and I can show you a demo. So I'll just conclude with that because we need to leave a few minutes for potential questions. So in summary, we have identified the key requirements for federated information sharing, and we have identified and developed, using a component-based approach, we have developed the key components of an access control policy language, and we use a policy engineering framework and apply software engineering principles to construct access management policies using the modular component-based approach. Our framework comprises of a policy language and a UML-based meta model. Among other things, we have a federation architecture to realize the framework. It consists of a SAML profile and a federation protocol to allow federated information sharing in a federated database system. And we have an application that we discussed, and we gave an example of a healthcare federation environment. As it turned out that our policy framework, although it's applied to a federated database schema architecture in my thesis or in my PhD dissertation, the framework, because of being based on well-known software engineering principles, presents a formal methodology which is more generally applicable, and we are currently looking at other areas such as policy-based community establishment in ad hoc networks and other complementary areas where similar approaches can be applied and can be useful. I guess that concludes what I had to say, and if you guys have any questions, we probably have 4 minutes and 30 seconds. They promise they're going to kick us out of here as soon as the clock says 5:20. Yeah, go ahead.
Okay.
I can hear you.
Okay,
yeah, it's for the TV, I guess.
Yeah, in the permission to role and user to role assignments, you had these logical operators.
Right.
You could use an and or an or.
Right.
Can you arbitrarily nest those?
Yes, that's a very good question. We can. I'll try to see if I can go back to that slide, and I try to put those curly brackets there to give you the idea that if you notice if you notice in the overall grammar, an assigned constraint can have multiple assigned conditions. Assigned condition is a set of logical expressions on a given credential type. A logical expression can have arbitrary number of predicates, and an assigned condition can also have arbitrary number of logical expressions inside it. So that's a very good question, and that's partly what adds to the maintainability and modularity and flexibility of our approach, that you can. This also has implications in the federated system because you can combine policies from multiple sources, and you can include that in your constraint evaluation. So yes. Anyone else who would have paid enough attention to ask more questions? All right.